Now, any inequality which is of the form fx upon gx greater than 0 or less than 0, greater than equal to or less than equal to is a rational inequality. So I'll take up a very simple example. X is greater than 1 by x. So this question is an example of a rational inequality. So we have some expression in the numerator, we also have some expression in the denominator. Now, how do we solve any rational inequality? Steps to solve any rational inequality, they are almost the same. Now, first thing that we need to keep in mind is I cannot cross multiply this x on the left hand side. So we cannot cross multiply in case of rational inequalities unless we are sure about the sign. So in this case, I cannot cross multiply. Maybe if the case is x is greater than 1 upon x square plus 1. So now when I know this x square plus 1, it's always positive. Now I can cross multiply. I can write x into x square plus 1 is greater than 1 because here I know it's always positive. So when I multiply with a positive number, sign doesn't change. So here multiplication is allowed. But in this case, if I'm going to cross multiply x square is greater than 1, here cross multiplication is not allowed. Now, how do we solve such question? Now, again, there are like same 5 steps. So the first step is make right hand side 0. So I'll make right hand side 0. X minus 1 upon x is greater than 0. Then factorize x square minus 1 upon x is greater than 0. So I'll simply write x minus 1, x plus 1 upon x greater than 0. Now find roots. Now in this case, in case of a rational inequality, I'll find roots of both numerator and also roots of denominator. So I need to find roots of numerator as well as roots of denominator and place all of them on a number line. So when I look at the roots, so the roots are x is 1, minus 1 and 0. So I'll actually put all the roots on a number line. So first minus 1, then 0 and then plus 1. Now then again I need to find sign of the rightmost interval. Now what about the sign of the rightmost? So here coefficient of x positive, positive, leading coefficient positive. So plus, plus and plus. So rightmost is plus. So this is plus, this is minus, this is plus and this is minus. Now what do I need? Now I'll go back to my inequality. It says greater than 0. Greater than 0 is obviously positive value. So I need plus. So this is from minus 1 to 0. And then from 1 to infinite. And then there's no equality sign. So I'll simply write x belongs to from minus 1 to 0 union from 1 to infinite, right? There are only two differences vis-a-vis polynomial inequality and rational inequality, and the one being here we'll take the roots of both numerator as well as denominator. So numerator is equal to 0 and denominator equal to 0. Now the second difference is when I have an equality sign. Suppose I have the same question, but here suppose we have an equality sign. X square is greater than or equal to 1 by x. So I'll solve the question in the same way. X minus 1 upon x greater than or equal to 0. Here also will be greater than or equal to 0. Here also will be greater than or equal to 0. Here again I'll take numerator and denominator. Here again I'll get all the three roots as minus 1, 1 and 0. I'll put them on number line. So now what's the difference? The difference being now there is an equality sign. So previously there was not an equality sign, so I could put all the open circles there. Now here we have an equality sign. So now if I put x as 1, I'll get 0. If I put x as minus 1, then also I'll get 0. But if I put x as 0, I won't get 0, I'll get infinite, either plus infinite or minus infinite, depending on the question, right? So that means if there is an equality sign, then we'll represent all the roots on a number line like we did previously, but then we can only include the roots of the numerator. We cannot include the roots of the denominator. So that means what are the roots of the numerator? So I'll include minus 1 and plus 1, but I'll exclude 0. So in this case, the answer will be x belongs to minus 1 to 0, minus 1 included, 0 not included, union, and then from 1 to infinite. So we are going to represent all the roots on a number line. I'm going to represent 1, minus 1 and 0 also, but then when I'm going to include them, I'll just include the roots of the numerator. I'll not include the roots of the denominator. So this is how we are going to solve these questions. So let me take up another example. X plus 4 upon x minus 2 is less than 2 upon x plus 1, and I need to solve this question. Now I cannot cross multiply because sign of both the expression, they'll change, so I cannot cross multiply. So I'll take it on the left hand side. I'll write x plus 4 upon x minus 2 minus 2 upon x plus 1 should be less than 0. So now I'll solve it. So x minus 2, x plus 1, x plus 4, x plus 1 minus 2, x minus 2 is less than 0. So what I'll get? I'll get x square minus 4x minus x plus 5x plus 4 and minus 2x plus 4 upon x minus 2, x plus 1 is less than 0. So I'll simply write it as what? X square plus 3x plus 8 upon x minus 2, x plus 1 is less than 0, right? So now I'll try and factorize this one, x square minus 3x plus 8. So when I look at this expression, what's the value of d here? So value of d is minus, b square is 9 minus 32, so which is less than 0. Now coefficient of x square is positive, so this is always positive. So rule number 1 says I'll remove this expression from the inequality. So that means the two roots that I have here is minus 1 and 2, and then sign of the rightmost is plus, minus and plus, and I'll need what? Less than 0. Less than 0 is minus. So answer to this question is x belongs to minus 1 to 2 and minus 1 and 2 not included. Now with rule number 1, we'll use rule number 2 because there is not an equality sign. But because this expression doesn't have a real root, so there is nothing to add or nothing to subtract, right? So I'll simply write x belongs to minus 1 to 2. So this is how we'll solve any rational inequalities. Now it's a multiple option correct question, so more than one option may be correct. So basically it's a rational inequality, and the inequality is 2x minus 1 upon 2x cube plus 3x square plus x, and it should be greater than 0. So I need to solve this inequality. Now first step, make right hand side 0, it's already 0. Second step, factorize. So 2x minus 1, so I'll take x common, and then I can also factorize it as 2x plus 1, and x plus 1 should be greater than 0. Next step, find roots. So roots are x is 1 by 2, 0, minus 1 by 2 and minus 1. Now place roots on a number line in order. So the smallest value is minus 1, followed by minus 1 by 2, and then 0, and then 1 by 2. Now what is the sign of the rightmost? Here coefficient of x is positive. Here the leading coefficient is also positive. So plus and plus, so rightmost is plus. So this is plus, minus, and plus. Now what do we need? We need greater than 0. Greater than 0 is obviously plus. So answer to this question is either x is less than minus 1, or it lies between minus half and 0, or it is greater than 1 by 2. Now we look at our options. Now in this question, it's not asking for the complete solution to this inequality. What it is actually asking for is the subset of the complete solution. Now I need to find out which of the following options they lie in the given solution. Now the first option is x is less than minus 3 by 2. So minus 3 by 2. So when x is less than minus 3 by 2, it does lie in the solution. So that means option A is correct. What about minus 3 by 2 and minus 1 by 4? So between minus 3 by 2 and minus 1 by 4, there is an interval where the solution doesn't hold, right? So that means this is not correct. Now between minus 1 by 4 and 1 by 2. So between minus 1 by 4 and 1 by 2, again there are certain intervals where this inequality is incorrect. So that means this is also not correct. Now what about 1 by 2 and 3? So 1 by 2 and 3, it does lie in the solution. So answer to this question is A and D. Now again, it's a rational inequality. Now in this question, I cannot cross multiply because x plus 1, it changes sign. So I cannot cross multiply on both sides. So what I actually need to do is, I'll take it on the left hand side. So this is 2x upon 2x square plus 5x plus 2 minus 1 upon x plus 1, and it should be greater than 0. So if I'll solve it, I'll get what? I'll get 2x into x plus 1 minus 2x square plus 5x plus 2 upon 2x square plus 5x plus 2 into x plus 1, and it should be greater than 0. So 2x square and 2x square will cancel. I'll get what? A minus 5x plus 2x minus 3x, and then minus 2. So I'll take minus common. So I'll get minus 3x plus 2. And if I'll factorize it, I'll get 2x plus 1, x plus 2, x plus 1, and it should be greater than 0. So if I'll write roots of this expression, what are the roots of this expression? So the roots are minus 2, minus 1, and then it will be minus 2 by 3, and then it will be minus 1 by 2. Now what is the sign of the rightmost? So this is minus, and then every other expression is plus. So plus, 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 and minus will be minus. So this is minus, plus, minus, plus, and then minus. So I need greater than 0. So greater than 0 lies in this interval. So between minus 2 and minus 1, and then between minus 2 by 3 and minus 1 by 2. And because it doesn't have an equality sign, so all of them they'll be in open circle. So answer to this question is x belongs to, so from minus 2 to minus 1 union minus 2 by 3 to minus 1 by 2. Question is, find the solution set of this inequality. I can write it as this is x plus 1 whole square. Now x cube minus 1, so this is x minus 1, x square plus x plus 1. I can take x common, and this is x minus 1, and this is greater than or equal to 0. Now I see an even power. So x plus 1 whole square. Now sign of inequality doesn't change. So rule number 1 says, if in my inequality I have any expression whose sign doesn't change, I'll remove that expression from the inequality, keeping the sign. So I'll remove it from the inequality. Now what about x square plus x plus 1? Now in case of x square plus x plus 1, the value of d is minus 3. So that means it has an imaginary root. A quadratic expression with imaginary root and positive leading coefficient is always positive. So that means x square plus x plus 1 is also always positive. So I can remove it from the inequality. Now what I see is, I see x minus 1 in the numerator and x minus 1 in the denominator also. So that means effectively there is no sign change at x minus 1. So I can remove x minus 1 from numerator and denominator both. But then since x minus 1 lies in the denominator, I need to write value of x cannot be 1. So what I'm left with is 1 upon x, and it should be greater than equal to 0. So what are the roots? Roots, it is 0. So rightmost is plus and then minus. So x is greater than 0. Now since x lies in the denominator, so I cannot include it. So that means there'll be an open circle. Now there are two more things that I need to take care of. First thing, the value of x cannot be 1. So I need to remove 1 from the solution because 1 doesn't lie in the domain of this question. And the second thing, now with rule number 1 comes rule number 3, and rule number 3 it says, if we have removed any expression in the inequality, then if the inequality contains an equality sign, I'll need to add the roots of the equation in the final solution. So what I have removed is x equal to minus 1. So I'll need to add this root to the final solution. So that means I need to add one more value, and this value is minus 1. So actually answer to this question is x belongs to minus 1 union 0 to 1 and union 1 to infinite. Now solve this inequality. Now in this question, I see an even power. Now rule number 1 says if there is any expression in the inequality which doesn't change sign, I'll remove the expression from the inequality keeping the sign. So I'll remove x minus 1 whole square. And about odd power, we already know we can remove the power. So I can simply write it as x into x plus 4 upon x plus 1 x minus 3, and it should be greater than equal to 0. So the roots are minus 4, minus 1, 0, and then 3. So what is the sign of the rightmost? Plus, 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 and plus. So sign of the rightmost is plus, minus, and then plus. Now what do I need? I need greater than or equal to 0. So greater than or equal to 0 is positive. So positive, it lies here, it lies in this interval, and it also lies here, right? And because there is an equality sign, so I'll include the roots of the numerator. So what are the roots of the numerator? Roots of the numerator, they are 0, and then it is -4. I'll exclude the roots of the denominator. So I'll not include -1, and I'll also not include 3. Now, because it has an equality sign, now with rule number 1 comes rule number 3. Now, rule number 3 says, if we have removed any expression in rule number 1, we'll need to add it in the final solution. So that means what I have removed? I have removed x equal to 1. So I'll need to add x equal to 1 in the final solution. So what I'll do is, I'll actually add x equals to 1. So answer to this question is, x belongs to minus infinite to -4 union, not included -1 to 0, union 1, union not included 3 to infinite. X to the power 4 into x plus 1 square into x minus 2 upon x minus 3 cube x plus 4, and it should be greater than 0, right? So now I need to solve this question. So this again is a rational inequality. So when I see even power, I know sign of expression doesn't change, so I'll remove this expression from the inequality. So I'll remove x to the power 4 and I'll remove x plus 1 whole square. Now for odd power, I can simply remove the power. I can simply write it as x minus 2, x minus 3, x plus 4, and it should be greater than 0. So the roots are -4, 2, and 3. So now this coefficient is positive. So positive, positive. So rightmost will be plus, minus, plus, and minus. So what do I need? I need plus. So I need this interval. So from -4 to 2, and then from 3 to infinite. Now with rule number 1 comes rule number 2. Because this question, it doesn't have an equality sign. So with rule number 1 comes rule number 2. Now rule number 2 says roots of the expressions which we have removed in rule number 1. So what we have removed in rule number 1? We have removed x equal to 0 and x equal to -1. So we need to remove these roots from the final solution if they are included in the solution. So -1, it's included, so I need to remove -1, and I'll also need to remove 0. So I need to remove both of these roots. So answer to this question finally will be x belongs to, so from -4 to -1, union -1 to 0, union 0 to 2, union 3 to infinite. So that is the answer to this question. Now, when I see this expression, it looks a little complicated, but what I can do is I can take these two together. So when I'm going to multiply it, I'll get what? X square minus 5x. And when I'm going to multiply these two also, I'll get x square minus 5x. So maybe I'll try and sort it out. I hope that it does work. So I'll take these two together. So I can write it as what? I can write it as x minus 1, x minus 4, and it'll be x minus 4 minus x minus 1. And then here I'll take 4 common. And here I'll write x minus 2, x minus 3, and then I'll write it as minus x minus 3, and then plus x minus 2, and this is less than 1/30, right? So when I'll solve it, here x and x will cancel. I'll get what? I'll get -4 plus 1. So this is -3. So -3, and this is x square minus 5x plus 4, and here I'll get what? Here I'll get minus and minus will cancel, and here I'll get plus 4 upon x square minus 5x plus 6, and this is less than 1/30. So this is less than 1/30. So if I take the LCM and then solve it, I'll get what? X minus 1, X minus 4, X minus 2, X minus 3, and then here I'll get minus 3x square plus 15x minus 18 plus 4x square minus 20x plus 16 is less than 1 by 30. So the condition I'll get is x square minus 5x minus 2 upon x square minus 5x plus 4 into x square minus 5x plus 6 is less than 1 by 30. So all I need to do in this question is I need to take x square minus 5x is y. So I can simply write it as y minus 2 upon y plus 4 or y plus 6, and then this is less than 1 by 30. So now solve this polynomial inequality in y and then finally get the answer in x. Now I can write it as 30y minus 60 minus y square plus 10y plus 24 upon 30 y plus 4 y plus 6 less than 0. So if I'll simplify, I can write it as minus y square minus 20y plus 84 divided by 30 y plus 4 y plus 6 less than 0. So if I'll factorize the numerator, I can write it as minus y minus 14 y minus 6 upon 30 y plus 4 y plus 6 less than 0. So now if I'll take a number line and if I mark all the points, I can write it as minus 6, minus 4, 6 and 14. Now sign of the rightmost is minus. So this is minus, plus, minus, plus and minus. Now what do we need? We need less than 0, which is minus. So the condition I'll get is y belongs to minus infinite to minus 6 union minus 4 to 6 union 14 to infinite. I'll need to find the values of x, not the values of y. So what I know is y is equal to x square minus 5x. So I need to write three cases. Case 1, when y is less than minus 6, which is x square minus 5x is less than minus 6, or y lies between minus 4 and 6, that is x square minus 5x lies between 4 and 6, or y is greater than 14, that is x square minus 5x should be greater than 14. Now I'll solve the first one. So I'll write x square minus 5x plus 6 is less than 0. So if I'll factorize, I'll get what? X minus 2, x minus 3 less than 0. So 2, 3 plus minus and plus. I need minus. So that is my first part, which is x should lie between 2 and 3. Now I'll solve the third part first. So this is x square minus 5x minus 14. It should be greater than 0. So which is x minus 7. X plus 2 should be greater than 0. So minus 2 and then 7. So plus, minus and plus. What I need is plus. So either it is less than minus 2 or greater than 7. So x belongs to minus infinite to minus 2 union 7 to infinite. Now coming to this second inequality, I need to take two separate cases. Case 1 and then case 2. So one is minus 4 is less than x square minus 5x and x square minus 5x is less than 6. So if I solve this first part, I can write it as x square minus 5x plus 4 is greater than 1, which is x minus 1. X minus 4 is greater than 0. So this is 1 and 4 plus minus and plus. I need plus. And for the second part, I'll write it as x square minus 5x minus 6 is less than 0, which is x plus 1. X minus 6 is less than 0. Minus 1 and then 6, which is plus, minus and plus. So I'll take minus. Now because there is an end condition, I'll need to take the intersection of the two solutions. So I'll plot both the solution on the same number line. So first one is less than 1 or greater than 4, and the second one is it should lie between minus 1 and 6. Now the interval which is common to both is x belongs to minus 1 to 1 union 4 to 6. Now all the three cases, the condition is OR, and when the condition is OR, we take union. So answer to this question will be x belongs to minus infinite to minus 2, union minus 1 to 1, union 2 to 3, union 4 to 6, union 7 to infinite. So this is how we solve these questions. Now for this question, I need to find domain of this function. So clearly there is a square root function. So I'll write mod of x minus 3, 2 minus mod x, x minus 2, and this should be greater than or equal to 0. Now for this one, roots are x equals plus or minus 3. For this expression, roots are x equals plus or minus 2. For denominator, it will be x equal to 0 and x equal to 2. Now because x equal to 2 features here and here at both the places, so effectively there will be no sign change at 2. So what I'll do is, I'll plot these numbers on a number line. So this is minus 3, minus 2, 0, and then here it will be 3. Now what is the sign of the rightmost? So plus, minus, plus and plus will be minus. So minus, plus, and minus. Now what do I need? I need greater than or equal to 0. So I need plus. Now because there is an equality sign, I have to include roots of the numerator. So roots of the numerator are plus 3 and minus 3 and minus 2, and I have to exclude roots of the denominator. Roots of the denominator are 0 and then 2. So answer to this question will be x belongs to, so from minus 3 to minus 2, union 0 to 2, union 2 to 3. Now you have to solve this inequality. So now in this case, now it's a rational inequality. So generally in rational inequality, we don't cross multiply, but in this case, when I see this x square plus 1, so x square plus 1 is always positive. So once I'm sure about the sign of the expression, I can cross multiply. So this is always positive. So I can simply write it as x square plus 6x minus 7 is less than equal to 2x square plus 2. So this is x square minus 6x. So I am taking everything on the right hand side. X square minus 6x and plus 9, and it should be greater than equal to 0. So what I'll get is, I'll get x minus 3 whole square is greater than or equal to 0. Now how do I solve this one? So now what I see is an even power. So any real number with even power is either 0 or greater than 0. So that means this is true for all x belongs to R. So solution to this inequality is x belongs to R from minus infinite to plus infinite, all the values. If x is an integer, then find the number of possible values of x so that x square minus 6x plus 5 is less than equal to 0 and x square minus 2x is greater than 0. So there are two polynomial inequalities. So what I'll do is I'll solve them separately. So make right hand side 0. It's already 0. So I'll factorize. So if I'll factorize, I'll get x minus 1, x minus 5 is less than equal to 0. Place roots on a number line. So this is 1 and this is 5. So this is plus, minus and plus. I need minus. So the value of x should lie between 1 and 5. X into x minus 2 is greater than 0. So the roots are 0 and then 2. So again, rightmost is plus, plus, minus and plus. What do I need? I need plus. So that means either x is less than 0 or x is greater than 2. Now I'll need to take intersection of both the condition because it's an end condition. So what I'll do is I'll represent both the solution on the same number line. So this is 1 and then this is 5. So first solution says x lies between 1 and 5 and the second solution says either x is less than 0 or x is greater than 2. So now the interval where both the conditions exist simultaneously is this interval. So answer to this question is x belongs to 2 not included and then 5 included. But in this question it was given that x is an integer, right? So I'll need to choose only integral values from this. So the integral values possible in this case are x is either 3, 4 or 5. So there are 3 values of x which is possible. Now basically it's a polynomial equation in 4th degree. But what I see here is I see a pattern here. So I see x square minus x here and I also see x square minus x there. So what I'll do is I'll start with I'll let x square minus xs maybe some y. So I'll write y minus 1, y minus 7 is less than minus 5. So I'll write y square minus y minus 7. So this is minus 8y. So plus 7 and then plus 5. So there'll be 12. So it is less than 0. And then 6 and 2. So I'll get y minus 2, y minus 6 less than 0. So condition I'll get is, so this is 2 and this is 6. So plus, minus and plus. So I'll need what? Less than 0 is minus. And both not included. So here the condition I'll get is the value of y should lie between 2 and 6. Now mind it, we need to solve the question in x, not in y. So what I'll actually do is I can write 2 and this is x square minus x is less than 6. So now I'll solve these two cases separately. So first I'll solve this case. So which is x square minus x is greater than 2 and x square minus x is less than 6. So if I'll solve it, I'll get what? X square minus x minus 2 is greater than 0. So I'll get x plus 1, x minus 2 greater than 0. So minus 1 and then 2. So this is plus, minus and plus. I need what? I need plus. So either x is less than minus 1 or x is greater than 2 and then both of them they are not included. Now what about this one? So for this one I'll write x square minus x minus 6 is less than 0. So x minus 3, x plus 2 is less than 0. So here will be minus 2 and then 3. So rightmost plus, minus and plus. I need minus, so it should lie between minus 2 and 3. So the interval where both of them exist simultaneously is either between minus 2 and minus 1 or between 2 and 3. So that is the answer to this question. 3x square x minus 4 square is less than 32 minus 5 and this is x minus 2 square. Now when I see this expression, what I know is I can also write it as this is 3 and this is x square minus 4x whole square and this is less than 32 and then minus 5. I can write it as x square minus 4x and then plus 4. So what I see here is I see x square minus 4x in both the places. So what I'll actually do is I'll take x square minus 4x as y. So I'll simply write it as 3y square is less than 32 minus 5 and this is y plus 4. So I can write it as 3y square plus 5y and then minus 12, it is less than 0. So this is 3y square plus 9y minus 4y minus 12 is less than 0. So I'll get 3y minus 4, y plus 3 is less than 0. So here I'll get y as minus 3 and y as 4 by 3. So now coefficient of y here is positive, it is also positive. So rightmost will be plus. So plus, minus and plus, I need what? I need less than 0. Less than 0 is minus. So the value of y will lie between minus 3 and 4 by 3. So the condition I'll get is the value of y should lie between 4 by 3 and minus 3. So now I'll put the value of y. So if I'll put the value of y, I'll get minus 3 is less than x square minus 4x is less than 4 by 3. So I'll take two separate cases. So case 1, when minus 3 is less than x square minus 4x, and when x square minus 4x is less than 4 by 3. So now I'll take it on the right hand side. So if I'll take it on the right hand side, I'll get x square minus 4x plus 3 should be greater than 0. So this is x minus 1, x minus 3 should be greater than 0. So here I'll get 1 and then 3. So this is plus, minus and plus. I need what? I need plus. So either x is less than minus 1 or x is greater than 3. Now when I'm going to solve the second one, here I'll get what? 3x square minus 12x and then minus 4, it should be less than 0. So here I cannot factorize it. So I'll simply write x as 12 plus minus b square and then plus 36 amounts. So I can actually write it as x equals to 12 plus minus 6 root 5 by 6. So this is 2 plus minus under root 5. So here I'll get 2 minus root 5 and then here will be 2 plus root 5. So rightmost is plus. So plus, minus and plus, I need minus. So value of x should lie between 2 minus root 5 to 2 plus root 5. Now I need to take intersection between these two conditions. So I'll plot both of them on the same number line. So the first one says x is less than 1 or x is greater than 3, and the second one says it should lie between 2 minus root 5 to 2 plus under root 5. So the interval where both the conditions exist simultaneously is first interval and then this is second interval. So answer to this question will be x belongs to 2 minus under root 5 to 1 union from 3 to 2 plus under root 5. So that is the answer to this question. So another fundamental that we'll study in inequalities is, now it has something to do with increasing and decreasing functions. So there are two kinds of functions. So the functions which are strictly increasing and the functions which are strictly decreasing. Now suppose I have two numbers a and b. So this is a and this is b, and these are their values fa and this is fb. Now in case of an increasing function, so if a is less than b, so obviously a lies on the left of b, it is less than b. So now tell me, value fa or fb, which is greater? So value at a is less than value at b. So fa is actually less than fb. So if a function is an increasing function, then if a is less than b, then fa is less than fb, or vice versa. So if in the neighborhood of a and b, fx is increasing, then sign of inequality does not change. But whereas in the case of a decreasing function, now suppose I have again two numbers a and b. So a again lies on the left of b. So a is less than b. Now this is your fa and that's your fb. So a is less than b, but then value at fa is actually greater than value at b. So in case of a decreasing function, sign of inequality reverses. So in case of increasing function, sign remains the same. In case of a decreasing function, sign reverses. Say for example, I'll say, suppose theta 1 is less than theta 2 and both these angles, they lie in the interval 0 to pi by 2. Now, if I take sine on both sides, sine theta 1, so sine theta 1 and sine theta 2. Now, recall sine, graph of sine x. So, in 0 to pi by 2, sine x is an increasing function, right? So, in 0 to pi by 2, sine x is an increasing function. So, when the function increases, sign of inequality does not change. So, I'll simply write sine theta 1 is less than sine theta 2. But when I look at the graph of cos, so now the graph of cos is from 0 to pi by 2, that's the graph of cos, right? Now cos x is the decreasing function. So if I write cos theta 1 and cos theta 2, so cos theta 1, now because it's a decreasing function, sign is going to change. So here it's a less than sign, now here it will be greater than sign. So cos theta 1 will actually be greater than cos theta 2. So that is the fundamental which we use in case of increasing and decreasing functions. So if function increases, sign doesn't change. If function decreases, sign reverses.